Okay, so let's get started. We're going to be taking a look at how to work with setting up Reluctor style engine speed reference and engine synchronization sensors within our Motec programming. Now, the last tutorial we reviewed how to set up and configure Hall effect style sensors. This is a little bit different, so we need to jump into some specifics here so we understand what to adjust, and then if we're having issues, what we can look for in terms of the tables that we need to actually adjust. All right, let's jump in and take a look at where we can find our area to program our cam and crank triggers for the Motec. We're going to move from our tuning area here and go into setup. Now under our setup area, we're going to move into the ref sync. This is going to house all the information we need for programming and working with our Reluctor sensors. So this should look familiar if you follow along to the last tutorial. A lot of what we have in terms of the programming information was relevant for the last application with a Hall effect cam and crank trigger setup. This is going to be a little bit different. I'm going through and setting up a distributor that's going to have a unique pattern, which we're going to learn how to program in here. And it's also going to be a little bit different than the Hall effect. Now we're dealing with a Reluctor style setup for both our engine speed reference and our engine synchronization. Now, first thing we need to do is actually go ahead and crank our engine over and take a look using our input capture option. So if we go up here to capture inputs, this will allow us to actually review what's going on with our specific pattern and start to generate some details we need for programming. So before you go through and set anything in your information right here, we're gonna go actually jump in, crank the engine over, and do that capture. Now I've ahead of time captured the engine cranking, the engine running at something like 2,000 RPM, and then the engine running between 4,000 and 5,000 RPM. We're going to need all this information to be able to populate things like our hysteresis tables here. It's very important when we're talking about a Reluctor sensor. Things will make a little bit more sense as we go through the training module. So let's jump in here to our capture inputs, and we're going to go up here to the top. Now I've provided in our training course folder sample captures from the vehicle I was working with, so you can follow along here on your particular laptop screen. So we're going to go here into import. So import a capture from a file, and that's going to lead us into the, let's go to our desktop. We're going to go down here into the Motec course, and we're going to jump in here to input sample. And then here we have a couple different options: distributor testing, cranking, 2,000 RPM, 4,000 RPM. I'm interested in cranking right now to see and determine some specific information. So let's go ahead and click open here. Now we find that we have our pattern brought up onto the screen, and let's open this up a little bit so we can see things in a little bit better detail. Now, the one thing you're going to notice from our previous training module talking about the Hall effect sensors, those were producing typically a 0 to 5 volt pulse. Now in my example that I was showing you on my engine simulator on the test bench, I was seeing somewhere between 0 to 10 to a 0 to 11 pulse when we were generating the square wave signal. That's because I was generating that and simulating it. Typically with a Hall effect, you're going to find 0 to 5 volt pulse. It's pretty standard. Now when we're talking about a Reluctor sensor for both our cam and crank, we're going to notice that we have a completely different type of look to the output, and this is going to be a sinusoidal wave. If we go in here, let's go ahead and use our up arrow, and we can focus in here a little bit. What we're going to find here is that we have the sinusoidal wave going up and growing in amplitude, then it drops, then it comes back to 0 again, essentially to the 0 threshold. So we'll find that if we're taking a look here, our engine speed reference, we can see there has a lot of pulses that are happening, a lot of waveforms that are happening, but the engine synchronization, we just have this single pulse. Now from this particular capture, what we're going to do is figure out what our actual engine speed reference tooth count's going to be. We know in this case that looking at this, we have a single pulse on our home or the synchronization. So on our cam trigger, we have one pulse, but how many actual crank teeth do we have? And that's what we need to populate for this information. So it's very, very basic. Let's go ahead and count this real quick and make sure we have everything correct. What I'm going to do here is start off counting my tooth right before or even right where the actual synchronization happens. I'm going to count from one synchronization pulse to the next in terms of the total teeth. That'll tell me for a full cycle how many teeth I have on my actual trigger. So here we can see right where that pulse starts, there's a synchronization, or a reference pulse I should say, right where the synchronization is going to begin. So I'm going to count this as 1. Then there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we can see the synchronization pulse will start right here, and that would be where it starts to count again. So we're ending our count on the tooth right before that synchronization tooth right here and right before that speed reference tooth right here. So we have these lining up to each other. We're going to skip that because that's going to essentially count as another cycle, and this is going to be where our last tooth here we're going to be referencing. So there's 24 teeth on our engine speed reference or our trigger, and then we only have one on the home. So that's going to allow us to program engine speed reference mode as well as our engine speed tooth count. And we also can use our start mode set here as sequential and support sequential operation with the Motec, because we do have this single pulse right here each cycle, which is important because we need that in order to determine the TDC position on our number one cylinder so that we can reference things like injection timing. All right, what we're going to do here is jump into our engine speed reference mode, and we're going to...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.